everyone, let us now discuss leveling adjustment. So there are two things that you can do to verify if your leveling has misclosure. The first thing is to connect the leveling back to the BM from which it started. Okay, so let's start with BM1 for example, and then as you go through your leveling route, if you want to check for misclosure, you can go back to BM1 and try to see if the computed elevation of BM1 after going through the leveling route is still the same as its original elevation. So if it's not the same, then you have misclosure. And the second thing that you can do is to connect into another BM of known value. Let's say you have a BM1 here, BM1 here, and you have your BM2 here with also with known value. So as you go through your leveling route, you check with BM2. So if you get the original, the known coordinates of BM2, then you don't have misclosure. But if there's a discrepancy then you definitely have misclosure. So what do we do with these errors of misclosure? So we distribute them, and it depends on what method that you want to use. But before we distribute the error, we must verify first if the misclosure is permissible. So if it does not fall within a certain accuracy standards, then that definitely have to redo your leveling. Okay, so what are these accuracy standards? Let's go here. So we have right here first order, second order, and third order. Okay, so first order is the most accurate, second order, followed by second order, and then third order. So the misclosure, if you're targeting, for example, first order, then your misclosure has to be equal to or lesser than this 4.8 millimeters multiplied by the square root of k. Now this k right here is the leveling distance in kilometers. Now we will use this in the example so you will know how to compute for this. Okay, so this is our example. Okay, let's examine the figure first. We have here elevation of A. Elevation of A is 20. This is the known elevation of K. And then we have here the leveling distances, 1.5, 0.8, 1, 1.9, and 0.5. And then we also have the computed elevation of B, C, D, and E, and also A. So as you can see right here, the computed elevation of A after going to the leveling route is 20.018. So definitely it has a misclosure, right? Our original is 20, but the computed is 20.018. So the first thing that we need to do is to calculate for the error. So the error is 20.00 minus 20.018. So the error is equal to negative 0.018 meters. Okay, or if you want to express it in millimeters, and that would be 18 millimeters, right? Okay, so we have 18 millimeters here. Okay, so now that we have our misclosure, now that we've determined it, let us now compute for the threshold that we want. So let's say our target is third order accuracy, then we need to use this one, right? So let's compute. First, we need to compute for the k, right? Which is the total level distance. So this is 1.5 plus 0.8 plus 1 plus 1.9 and then plus 0.5. So k here will be equal to 5.7 kilometers. Now that we have our k, we can then input that into the formula, square root of 5.7 kilometers. So if we multiply this, you will get 28.65 millimeters. Okay, so let's focus on the magnitude of the error. You don't necessarily need the sign here. So we have 18 millimeters. It is well within the 28.65. Therefore, this misclosure is permissible. Therefore, we can proceed to error distribution. Okay, let's start the error distribution. Okay, so first thing that we need to do is to determine the error So this is C per kilometer. That is equal to negative 0.018. This is our total error divided by 5.7 kilometers, which is the total leveling distance. Now, if you do that operation, you will get this value. So you have the option to round this. I didn't round this because just a personal preference. So let's calculate for the individual corrections. Let's say you want to calculate for the correction of B, point B. Let's start with point B until we reach point A. Okay, so B here, so is equal to this value, C per kilometer, multiplied by 1.5. As you can see here, this is the distance from A, 1.5, is equal to negative 0.005. So how about for C? So you will get C per kilometer right here multiplied by 2.3. This is one right here. So this is equal to negative 0.007. And then CD, correction for D, that would be multiplied by 3.3. That would be negative 0.010. And then CE, that would be C per kilometer multiplied by 5.2. So that would be negative 0.016. And then finally for A, we get C per kilometer multiplied by 5.7. That would be negative 0.018. Okay, so let's tabulate these values. Okay, we have here negative 0.005. Oh, let's write it in another color. Let's say blue. Negative 0.005, and then negative 0.007, and then negative 0.010, negative 0.016, and then negative 0.018. Okay, so if we subtract it from the observed, this will be, subtract these values from the observed, or add these negative values, we will then get this one, 28.561, 35.003, and 30.640, 22.829, and then 20.000. Okay, so there we have it, our adjusted elevations for our benchmarks. This is our final answer. Okay, so that's it for adjustment of leveling routes. So thank you for watching this video. See you in the next videos.